if we can show that the series whose terms are the absolute value of an converges, then the series whose terms are just an is also going to converge. That gives us an important strategy for convergence, for showing convergence of series with positive and negative terms. That strategy is going to be to try to show convergence of the series formed from the absolute value of the terms. So if we can show convergence using integral test, comparison test, for example, or limit comparison test, then that will imply convergence of our series. If this series AN diverges, it does not. Mean that our series has to diverge. It could still conditionally converge, though it may diverge. Okay. All right, so let's take a look and see why this is true. So if we have a series with just positive terms, then and it converges, then the series with side terms is also going to converge. Let's show this theorem. So we're assuming that we know that the absolute value of an, the series whose terms are the absolute values of an, converges. Okay. And we're going to do a cute comparison test. So 0 is less than or equal to an plus the absolute value of an. If an is negative, then when we add it to the absolute value of an, we're going to get 0. If it's positive, then we'll get twice the absolute value of an. So this is true for all n. And therefore, the series an plus the absolute value of an converges, since 2 times the absolute value of an converges, since this second series converges. Okay, this is the comparison test. So if we found a bigger series that converges, then our smaller one converges too, as long as, so notice we needed that we had all positive terms. Okay, so we have these two convergence series. All right, and here's where the magic happens. We can write the series an as an plus the absolute value of an minus the absolute value of an. Okay, so we get an plus the absolute value of an minus the absolute value of an. Since this series converges and this series converges, the difference of these two series is the the sum of the series with terms A n. And that proves it.